Welcome to the MBS Engineering channel. Today, we will understand how to calculate the area of thermal expansion. Next, we will discuss this topic in the upcoming slides. The following topics will be addressed today. The first topic is what thermal expansion is. The second topic is types of thermal expansion. The third topic is how to calculate the final area of the thermal expansion. The fourth topic is how to calculate the final temperature of the thermal expansion. Next, we will discuss the above topics in the upcoming slides. Next, we will discuss the thermal expansion. Next, we will understand and discuss what is the thermal expansion. Thermal expansion can be defined as the change in the length, width, height, or volume of any material when temperature changes. Next, an object changes its dimension in length or volume as a result of heat is known as thermal expansion. Next, we will understand and learn the types of thermal expansion. The first type is the linear expansion. Linear expansion is defined as the increase in the length of the solid as a result of the heating process. The second type is the volumetric expansion. The volume expansion is defined as the increase in the volume of the solid as a result of the heating process. The third type is the area expansion. The area expansion is defined as the increase in the surface area of the solid as a result of the heating process. Next, we will learn and understand the formula for the area thermal expansion. Area expansion occurs when a material expands or contracts in two dimensions. The formula is used to calculate the area expansion as follows. Delta A is equals to alpha A into AO into delta T. Here. Next, AO is the initial area of the solid. Next, delta A is the change in area. Next, alpha A is the area expansion coefficient. Next, delta T is the temperature difference. Next, we will learn and understand how to calculate the final area of the thermal expansion. At 20 degrees Celsius, the dimensions of a sheet are 60 centimeters in length and 30 centimeters in width. Given that the coefficient of linear thermal expansion for steel is 10⁻⁵ per degree Celsius, we need to calculate the change in area and the final area of the sheet when the temperature rises to 60 degrees Celsius. Here. Next, AO is the initial area of the sheet. It means length into width, so 60 centimeters into 30 centimeters. Therefore, the initial area AO is 1800 centimeters square. Next, delta T is the temperature difference. The final temperature is 60 degrees Celsius, minus the initial temperature is 20 degrees Celsius. Therefore, the delta T or the temperature difference is 40 degrees Celsius. Next, delta A is the change in area. We need to calculate the delta A. Next, alpha L is the linear expansion coefficient, 10⁻⁵ per degree Celsius. Next, alpha A is the area expansion coefficient for the sheet. We need to calculate the area expansion coefficient. The formula for calculating the coefficient of area expansion for sheet alpha A is 2 multiplied by linear expansion coefficient alpha L. Therefore, the area expansion coefficient is 2 into 10⁻⁵ per degree Celsius. Next, the formula is used to calculate the area expansion as follows. Delta A is equals to alpha A into AO into delta T. Apply the given data. We get the change in area, delta A. Next, delta A is equals to 2 into 10⁻⁵ per degree Celsius into 1800 centimeters square into 40 degrees Celsius. Next, the change in area or delta A is 1.44 centimeters square. Next, we need to calculate the final area at 60 degrees Celsius. Next, the final area is equals to the initial area AO, plus the change in area delta A. So, The final area is 1800 centimeter square plus 1.44 centimeter square. Therefore, the final area AF is 1801.44 centimeter square. Therefore, the final area AF at 60 degrees Celsius is 1801.44 centimeters square. Next, we will learn and understand how to calculate the thermal expansion final temperature. At 35 degrees Celsius, the area of a sheet of aluminium is 50 square centimeters, and the coefficient of linear expansion is 24 into 10 power minus 6 per degree Celsius. Determine the final temperature if the final area is 50.2 square centimeters. Here. Next, AO is the initial area of the sheet is 50 centimeters square. Next, AF is the final area of the sheet is 50.2 centimeters square. Therefore, delta A is the change in area, final area 50.2 centimeters square, minus 50 centimeters square. Therefore, delta A, or change in area is 0.2 centimeters square. Next, TO is the initial temperature of the sheet is 35 degrees Celsius. Next, TF is the final temperature of the sheet, we need to calculate it. Next, alpha L is the linear expansion coefficient, 24 into 10 power minus 6 per degree Celsius. Next, alpha A is the area expansion coefficient for the sheet, we need to calculate the area expansion coefficient. The formula for calculating the coefficient of area expansion for sheet alpha A is 2 multiplied by linear expansion coefficient alpha L. Therefore, the area expansion coefficient is 2 into 24 into 10 power minus 6 per degree Celsius. Therefore, the area expansion coefficient alpha A is 48 into 10 power minus 6 per degree Celsius. The formula is used to calculate the area expansion as follows. Delta A is equals to alpha A into AO into delta T. We need to calculate the final temperature, so apply the minor changes in the above formula. Delta A is equals to alpha A into AO into final temperature TF minus initial temperature TO. Apply the given data, we get the final temperature TO. 0.2 is equals to 48 into 10 power minus 6 per degree Celsius, into 50, into TF minus 35. 0.2 is equals to 2400 into 10 power minus 6 per degree Celsius, into TF minus 35. Next, 0.2 is divided by 2400 into 10 power minus 6 per degree Celsius is equals to TF minus 35. Next, 83.333 is equals to TF minus 35. Therefore, TF is equals 83.333 plus 35. Therefore, TF is 118.333 degrees Celsius. Therefore, the final temperature TF is 118.333 degrees Celsius. We hope everyone understands the formula and how to calculate the area of thermal expansion and final area of the thermal expansion and then the final temperature of the thermal expansion. Thank you for watching. Don't forget to subscribe to the channel for more informative videos. Please like and leave a comment.